friends, so today we will discuss GSET questions of P block elements. We are starting from 2002 and we will go up to 2019. Okay, so first 4 questions are from 2002 GSET and fifth question is from 2004. So let us discuss one by one. So first question is, the most important mineral for isolation of PB is, lead के लिए most important mineral from which it can be isolated, means which ore is most important for isolation. So you know, if we talk about lead, first of all in our mind comes galena. Galena is PBS, lead sulfide. So in most of the cases when lead is mined, main component is galena, and this anglesite is actually lead sulfate. And you know, lead sulfate is found, I can write here, lead sulfate, anglesite is lead sulfate. It is the oxidation product of galena. Cerussite, it is actually lead carbonate, and it is found locally in, means very few cases we get cerussite as the ore. And pyromorphite, this is actually lead chlorophosphate. Okay, and this one is Pb5 PO4 thrice Cl. This is also found locally as an ore. Okay, so in our question answer is galena, that is lead sulfide, right? So first question we take it as, it is 2002 question and answer is galena, right? Now come to second question. Which trend is correct for XX, single bond dissociation energy of the diatomic halogen? So you know, in case of FF, II, BR, and CL, if we talk about bond length, so you know, bond length is minimum in fluorine and maximum in iodine, right? Because you know, fluorine, chlorine, bromine, iodine, this is the trend of size. Size increases down the group, so obviously bond length increases, and you know, bond length and bond strength are inversely proportional. So bond length is inversely proportional to bond strength or bond energy, right? So if we talk about bond length, so bond length is maximum in iodine, so trend should be II minimum, then BR, then CL, and then FF. This should be the case. But keep in mind, because of exceptionally small size of fluorine, this trend is not correct. Because of exceptionally small size of fluorine, there is large inter-electronic repulsion between non-bonded electron pairs. Large inter-electronic repulsion between non-bonded pairs, and because of this, FF bond dissociation energy is less than expected. So trend is actually maximum is Cl because of more inter-electron repulsion owing to their small size. Chlorine, and then bromine, and then fluorine, and at the end iodine because of their very large size. Okay, so this is the trend. So should be Cl2. This is not the case. This will not also. No option is correct. Actual option should be this one. Cl greater than Br, which in turn greater than Ff, then II. Means trend should be Cl2 greater than Br2, then F2, and at the end I2. Right? So in this question, no option is correct. Now question number 3. Which of the following salts is a good reducing agent? So out of these, very good reducing agents are, in organic chemistry, main reducing agent we use, these are lithium aluminum hydride and sodium borohydride. Okay, because of the BH4 negative, which can give H negative here AlH4 negative, which can give H negative. So obviously good reducing agent is sodium borohydride. If lithium aluminum hydride is there, then lithium aluminum hydride is better than sodium borohydride. Why? Because it is easier to break AlH bond than BH bond, because aluminum is larger in size. Okay, so this question is very easy. Now for oxygen and ozone, which of the following statements is not true? First, both are allotropes. Yes, O2 and O3 both are allotropes of oxygen. Then passing electricity through oxygen produces ozone. So when silent electric discharge means sparkless light is passed through O2, silent electric discharge means electricity is passed through it, but it should not produce spark, right? Silent. So we get O, and then O2 react with O to give O3, right? So this is true. Now O3 contains pi bond. In O2, O3, this is the case, and this is in resonance with this. That means resonance hybrid is O. This pi bond is delocalized. Okay, so O3 contains pi bond delocalized over 3 oxygen atoms, right? But in oxygen there is no such case. Okay, because there is only 2 atoms. There is no delocalization, right? Oxygen is, so A statement is correct, B statement is correct, C statement is correct. Oxygen is strong oxidizing agent, right? But if we compare, because there is a comparison, oxygen and ozone. So if we compare O2 and ozone, ozone can give nascent oxygen easily. So ozone is better oxidizing agent than O2. So it should be ozone is strong oxidizing agent. That means this statement is not true. Right? Okay. Now come to next. Next is, these are the questions up to 4. These are the questions from 2002 GSET. December and January. And fifth question is from 2004 GSET. Oxygen's number of iodine varies from -1 to +1, -1 to +7, +3 to +5, and -1 to +5. So you know iodine is halogen. Iodine is halogen having general configuration NS2 and P5. So it gains one electron to complete its octet. So minimum oxygen number is -1, and it can lose maximum of 7 electrons, 2 plus 5, right? Because it has 7 valence electrons. So maximum oxidation number is +7. So it varies from -1 to +7, right? So these are first 5 questions. Then we will I will write another questions and then we will proceed further. Now question number 6. Question number 6 is choose the equation which illustrate that H2SO4 act as dehydrating agent. So you know what is dehydrating agent? Dehydrating agent means which can absorb water or which can remove water from the given compound. Okay, so see, in first case there is a removal of water because it has hydrogen, it has oxygen. In second case, you know, zinc, how can water is removed from zinc? Again zinc carbonate, no hydrogen and oxygen, so there is only one option, because when concentrated H2SO4 is added, there is a formation of charcoal, carbon, along with removal of water. So option A is correct. Got it? Okay, very good. This is very simple question, because dehydration means removal of water. Hydration means addition of water. This is question from 2004 as well, 5th and 6th. Now 7th and 8th questions are from 2006 GSET 2006. Now super acids are useful as, first, what is super acids? So keep in mind, super acids are those acids which are stronger than 100% pure sulfuric acid. More stronger means stronger than, more powerful H plus ion donor than 100% pure sulfuric acid, right? So for example, chlorosulfuric acid, fluorosulfuric acid, even oleum is also under the category of super acids. Okay, so they are actually used as catalysts. Okay, there are so many functions of it, but main is it acts as a catalyst, like oleum in the nitration of benzene, we use it. Okay, so what about 8th question? Which of the following is obtained by the process of electrolysis? So you know, electrolysis process is used for strong reducing agents. It is used for strong reducing agents. So you know, out of these, which one is strongest reducing agent? Obviously aluminium. So aluminium, sodium, magnesium, they are alkali metals, alkaline earth metals, aluminium, they are obtained by the process of electrolysis, right? Because it is difficult to find out stronger reducing agent than these metals. Okay, that's why they are obtained by the process of electrolysis. Okay, great. Now question number 9 and 10 are from GSET 2008. Question is maximum number of covalent bonds formed by boron. Very easy question. You know boron. Boron is 1s2, 2s2, 2p1. So if we write its ground state, it is like this: 2s2, 2p1. In excited state, unpaired electrons, so it can form 3 covalent bonds, but keep in mind one orbital is vacant. Okay, so maximum bonds that it can form are 4 in number. Okay, so it can form maximum number of covalent bond as 4 because it has 4 valence orbitals. Because of the presence of 4 valence orbitals, it can form 4 covalent bonds. Okay, keep in mind coordinate bond is also treated as a covalent bond. Okay, done. Graphite. Next question. Graphite has sheet structure, that you know. There are hexagonal layers. Graphite has hexagonal layered structures. So when these layered structures interact with each other by van der Waals interaction. There is a van der Waals interaction between these layers. That's why these layers are slippery. One can slip over other. That is responsible for the lubricant nature of graphite. Okay, and they are conducting. One electron is free per carbon atom because each carbon atom is sp2 hybridized. But conductivity is within the layers. Okay, but slippery nature is because one layer can slip over other easily because there is van der Waals interaction between the layers. Okay, so there is van der Waals interaction between the layers. Okay, now last 11th question is from 2010. Which of the following halogens is solid at room temperature? Keep in mind that halogens are gases, liquids as well as solid. All the 3 states of matter are present in halogens. So you know, fluorine, chlorine, bromine, iodine, as we go down the group, size increases, molecular mass increases, number of electrons increases, and that's why dispersion forces, van der Waals attractions increases as we go down the group, right? So fluorine and chlorine, they are gases because of weak van der Waals attraction, slightly stronger in Br2, that's why Br2 is a liquid, because there are only dispersion forces as they are non-polar, and iodine being large in size and high molecular mass, it is solid. So see, only liquid halogen is bromine and solid halogen is iodine. So iodine is the right answer. Okay, so it is up to 2010. Now let us do next one. Question number 12, 13 and 14. They are from GSET 2011. So first question is the number of POP bonds in cyclic metaphosphoric acid. So actually cyclic metaphosphoric acid, we can write it like this. This is a structure. So how many POP bonds are there? See, 1, 2 and 3. So right answer is 3. So number of POP bonds in cyclic metaphosphoric acid are 3. Okay. Now come to next question. So next question is sodium thiosulfate is prepared by, very easy question, asked in most of the exams. See, the answer is sodium thiosulfate when boiled with sulfur in acidic medium, we get sodium thiosulfate, right? See, in alkaline medium it cannot be formed. This is the right answer, but if we reduce it, sodium sulfate with H2S, then we will get Na2S along with H2SO2. Keep in mind, okay? And if we neutralize H2S2O3 with NaOH, so instead of getting Na2S2O3, we get Na2SO3, sulfur and water, right? That's why right option is A. Okay. Now, which statement is not true about diamond? Just read the statements. First is carbon is sp3 hybridized. True, because each carbon in diamond is sp3 hybridized. Right? And so on. There is network of covalent bonds and each carbon forms 4 bonds. Right? So first option is true. We should find out not true. It cannot be synthesized from graphite. Right? Not right, because it can be prepared from graphite. So that means this statement is not true. Okay? Diamond and graphite, vice versa. From diamond we can prepare graphite, and from graphite we can prepare diamond by adjusting the temperature, pressure and catalyst. Okay? It is hardest naturally occurring substance, right? It is thermodynamically not stable form of carbon, right? Because thermodynamically most stable form of carbon is graphite. Okay? So A, C and D options are correct. Only this option, B option, is not correct. So these are the 3 questions, 12, 13 and 14 from GSET 2011. 15, 16, 17, 18 and 19. These are the questions from GSET 2013. Okay. So 15th question is, which of the following alkali metal compounds with noble gas are most stable? So see, in first case, what is the oxidation? First of all, calculate the oxidation number of xenon. See, this is plus 3. Here it is plus 6. In this case, it is plus 5. And here it is again plus 6. So, most oxidized form of xenon is B and D. So, we have to choose between B and D. And you know, D compound does not exist because xenon cannot accommodate 9 fluoride ions around it. Okay, but it can easily accommodate up to 8 fluoride ions. Okay, that's why M2XeF8 is the most stable form of alkali metal compound with noble gases. Okay, M2XeF8, where there is an ionic bond between metal and xenon. You know, it is M2 total 2 plus and XeF8 2 negative. Right? Yes. So this is the correct option of question number 15. Now 16. Which is the strongest acid among the following? So you know which one is strongest acid? This is Ha. When it give H plus ion, first, though that acid is strong, which can easily release H plus, ease to release H plus, and second, stability of the anion formed. So more stable is the anion formed, stronger is the acid. First, ease to release H plus, and second, stability of the anion formed. Okay, or we can say conjugate base. This is acid, So it is conjugate base, right? So if we see the oxidation numbers, here it is plus 5 plus 6 plus 4 and plus 7. So oxidation state tells the story. This is more stable, and at the same time ClO4 negative. In ClO4 negative, negative charge is delocalized on 4 oxygen atoms. So due to delocalization of negative charge, there is minus 1 by 4 charge on each oxygen. Okay, and that's why this is most acidic, or we can say strongest acid among these particular acids, right? Okay. Now next, anhydrous aluminum chloride fumes in moist air. Why is it so? Because aluminum chloride, it is electron deficient compound. It is an electron deficient compound. So water can easily attack on it because of the presence of vacant orbital. Okay, because it is electron deficient, and that's why it can fumes in moisture, because it gives HCl along with AlOH4 negative, right? And that means anhydrous aluminum chloride fumes in moist air because it is readily hydrolyzed. Okay, why it is hydrolyzed? Because water can easily attack on aluminium because of its electron deficiency, right? Okay, great. Now come to next, bone charcoal. It is also called animal charcoal, is used for decolorizing sugar. This is a question of surface chemistry as well as P block, because charcoal, it is application of carbon, so comes under group 14. Right? Then bone charcoal decolorizes sugar because raw sugar has brown color, and that dye is adsorbed. What I said? Adsorbed by charcoal, and that's why it decolorizes, because it absorbs, bone charcoal absorbs coloring matter, right? Now next one, which of the following ionic species does not exist? So see, tin, silicon, carbon and germanium. Second period elements, can form maximum of 4 bonds because of the absence of vacant d orbital, because they have only 4 orbitals, 2s and 1 2s and 3 2p. 2d does not exist. That's why carbon, even boron, carbon, nitrogen, oxygen, fluorine, they cannot form 6 bonds. Here in all there are 6 bonds, so that means carbon CCl6 does not exist. So that's all up to GSET 2013 questions. We will continue the next lecture from 2014. Okay, note up to this and wait for the next lecture. So thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning.